Hello, my name is John Pavlik, and today we're here at the Irvine Institute of Technology located in Irvine, California. This state-of-the-art teaching facility was built in 1996 by Dr. C.V. Chellapati, the founder of the Institute. One of the many classes we offer here is called Engineering Surveying. This class is designed to help civil engineers prepare for the California Professional Engineer Licensing Exam. One afternoon of this class is spent looking at the equipment and methods used in engineering surveying. Please join me as we do that today. To our field demonstration. We've been doing this for about 6 or 7 years now. We get excellent feedback from everybody. This is an opportunity for you guys to get some hands-on experience and see at all the stuff that I was talking about in class this morning. So, you know, when I was looking through the pencil this morning, we're actually going to be looking through some real instruments today. We'll have some volunteers. Where's Alec at? Yeah, he's going to be our first volunteer. He already volunteered. He's very excited about it. And he even looks like a surveyor, doesn't he, Kurt? I think he can fit right in here. Okay, I'd like to introduce first my buddy Kurt Hohen, and this is Charlie Bill. They work for a company, Kurt's company. It's called HB Land Surveying. And if you need any surveying of any kind, anywhere, any place, Kurt's your man. He's just got a little small operation, low overhead. He does a great job at a great price. So, and he's got some business cards we'll hand out afterwards if you have anything that you might need. Kurt's the guy for you. Okay, and then Charlie actually works with him. And our friend Tim over there is going to be our videographer today. And the first thing we want to do is we want to talk about the surveyor's dress and equipment. And when we're out in the field working, you got to remember it's not like being at your desk where you can go grab a pencil or a calculator or whatever. Oftentimes you're maybe a half a mile or a mile away from the truck, so you have to have everything on your person. So you'll see how Kurt is dressed. Usually you got to have a hat and sunglasses and long sleeve shirts and everything. Skin cancer, like every surveyor that I know had his bout with skin cancer, and that's not a good thing. So we kind of like dress to protect ourselves from that. The red vest you'll see here, I think that's red, isn't it?
This side is.
There you go. And the red vest is something that's used not only for safety purposes, but it's used for storage. And if you're out in the field working in the traffic, don't think that the red vest makes you invincible. It actually just makes you a better target. So you need to be careful when you're working out in the street. And like I said, it's also used for storage, so all of Kurt's pencils and notebooks and papers and everything like that, he keeps right there. And then in the back, got additional storage back there. And then Kurt, you'll see, has a chaining belt on. That's what this is called, a chaining belt. And it has all of the equipment that you need throughout the day. And we'll start off with the Plumb Bob that we talked about, and I think you've all seen a Plumb Bob before, and this is used when we chain. And there's different size of Plumb Bobs. Most people use a 16-ounce Plumb Bob, so it doesn't do much swinging around, or some people use a little tiny one. And this right here is called a gammon reel. And what this does, it kind of keeps your string out of the way. If you look at the old-fashioned ones, they just had a piece of string and you had to wrap it around your neck. And next thing you know, you're all like choking yourself and everything. So this guy named Gammon that used to work for Caltrans invented this thing in the late 60s, the 1960s. And of course, he's gone on to become rich and famous, and he's one of the icons of the surveying business. It's one of those stupid little things like, hey, why didn't I think of that? And now Mr. Gammon's down there in the Caribbean in his yacht and having a good old time. And we're all buying his gammon reels. So this is also used for a target. So if you were far away and you wanted to have the surveyor's sight on a point, you could plumb yourself over that point and they would go ahead and look at this target here and be able to get what's called line on that point. And the Plumb Bob's kind of the international symbol for surveyors. So if you saw one of these with like a big X through it, on a front door of someplace, that would probably mean something like no surveyors are allowed here.
Normally that's involved.
And that's usually the first place we try to get into. Also, I talked this morning about yo-yos. It's actually just a pocket tape. And these are used for short measurements. They're also used to measure the HI. Remember, I told you about that this morning. And to measure the HI, you would go ahead then and measure from the ground up to the center of collimation on the instrument. And just simply note that somewhere. And this was 33 feet, so you can measure a lot of distances with that one. And also you'll see that he's got his calculator there that's used. Remember this morning I talked about the hand level. And unfortunately we don't have any topography here, but let's say if Charlie and, what's your name again? Charlie and Kurt were chaining up a hill, and if Kurt was on the, let's see now, if you were on the uphill side, the downhill side, actually, yeah, the downhill side, and Charlie was on the uphill side, what Kurt would do would be to move himself up and down like this until he was level with Charlie, and then that we would know we were measuring horizontally and not a slope distance, okay? So I'll go ahead and pass this around and you can look through this.
This is the top here, and
oh, yeah.
As the sun gets in there, the bubbles level.
Yeah, what he said. So the bubble looks there, and you can see when the bubble crosses the crosshair, that means you're level with whatever you're looking at. So I'll go ahead and pass that around. Alex, the first one to grab that too, man. He's into this stuff, I'll tell you. Here is what's called a right angle prism. This morning, remember I talked about two kinds of tie-ins. What were those, remember? Rectangular and polar, excellent. Okay, and one of the ways we talked about the rectangular tie-ins, remember it's kind of a plus and out situation. So if we established a baseline along here and we wanted to establish a distance along the baseline and measure out to a point, we'd first have to get to a point along the line that's perpendicular to that point. So this is kind of a cool thing. You can actually look in three directions at the same time. So I can look forward, and I can look left, and I can look right. So if I wanted, if we had a baseline along here and I wanted to be 90 degrees to that signpost behind us, I could just move along here until I was at, and then I would mark the point right here, and then I would measure along the baseline and then measure a distance out, and that would give us a rectangular tie into that. So I'll go ahead and pass this around too here. Here you go, Alec, you get to look at it first. And what else do we have here, Kurt? We've got, let's see, your hand level. We got the chaining. One of the things, this is called a tack ball here, and the tack ball is used to keep these little tacks in. Sometimes we set a monument on the ground that's actually a wooden monument. So if we pounded one of these in the ground, that's not a very definitive answer as to where our survey point is it. So what we usually do to get a more definitive answer is take one of these tacks and put it exactly somewhere on here where the exact point is, okay? So that's what these tacks are used for. And speaking of survey monuments, let's look over here to the right. It's freaking you out, isn't it? Three ways at the same time. Okay, when we talk about survey monuments, these are some examples of survey monuments that we set in the ground. These are, and also these are some tags that are set along, in addition to the monuments. So see these big round ones up here? These are horizontal control stations. The one with the triangle here, that's a horizontal control station. And this one with the bump on top is a benchmark. It is actually labeled benchmark. And this one here is for a section corner. And we'll talk about the public land survey system next week. And these are some of the similar monuments. These are brass, these are aluminum. Also, you'll see some tags down here. These tags are set with some of these monuments here. So you could set what's called a spike and tag. So this spike would be pounded vertically into the ground, and it would be tagged with one of these monuments. Now, as a licensed land surveyor, you have a registration number. Like mine's LS 5168. What's yours, number 2 or something like that, right? No, he's
We'll favor that.
Kurt's has I think his is a little bit smaller than me.
4874.
4874. And when you set a bound,
LS, not RCE.
that's right, LS, yeah. And when you set a monument, you have to have your tag on there, and that lets the whole world, John Pavlik or Kurt Hohen set this monument. So if you're out doing another survey, a retracement survey, let's say on an adjoining property, and remember, your boundary is the adjoiner's boundary also, right? So if there were any questions about the location of the monument, the other surveyor could look at the tag and say, okay, that's LS 5168. There's those Harley people I told you about. You could look, and then you could look it up, go on the website and say, okay, who's LS 5168, John Pavlik, and then it would give contact information for me. One of the things that you want to do after you get your RCE, and you will, you have to maintain contact with the Board of Registration. They have to always know where you live. And you also have to keep your registration current. Every 2 years, $160 some. Every 2 years. If you let your license lapse for 2 years, guess what happens? You got to take it all over again. And God, we don't want to do that now, do we? Okay? So remember, you're responsible to keep in contact with the board and let them know where you are. Yes?
The Orange County, they have the triangle which means that horizontal control. Is that the same throughout whole county? Like all the county has the
Okay,
same idea?
good question is, this monument has a triangle that indicates horizontal control. Does everybody use that symbol? It's kind of universal, but not everybody uses it. Normally a circle would indicate vertical and a triangle indicates horizontal, but it doesn't have to be that way.
Section.
This is a section line. What they do is they stamp in the section corners on each of the side. And when we talk about public lands, that'll become a little bit clearer. Now,
I have a question.
yes.
I once did a project in which we had the, epoch tide levels, and then they had buoys on which those things were marked. How would they look? They would also look like this with a benchmark on top of it?
Okay, were they benchmarks?
That's what they call them?
Title benchmarks.
Yeah.
Title benchmarks. Title benchmarks, now this is just like an example of a monument, okay? Many different things are used for monumentation. All right, back in the old days, like in the 1800s, they would use like rock mounds, whiskey bottles. I mean, a lot of weird stuff that they use for monuments. They would use redwood posts. What else are some of the things? Fire pits. They would like dig a big pit and set a fire in it so the ashes would be there like forever. They would blaze trees that would be there forever, and those kind of things. Another thing that you'll often see on a map is set 1-inch iron pipe. So a lot of people are going, wow, I mean, is the pipe like going this way? No, it's actually pounded into the ground vertically, and then a tag would be put on top letting everybody in the world know this is who set this monument. And then most of the time they'll dig out a big hole and fill it up with concrete and then backfill it with dirt on top. So surveying monuments are supposed to be perpetual, which means they're supposed to last forever. So a lot of monuments and remember, we live in a pretty urban area, but when we go out into some of the lands like in Riverside County that were surveyed back in the early 1900s, we actually can find original monuments that are like almost 100 years old. So it's pretty cool to go out there and do a retracement survey and find a monument in the ground that was set like 80 or 90 years ago. And you're there, and you might be the only person that had been there in the past 90 years. So it's pretty cool when that kind of thing happens. So if you see the term 1-inch pipe or 2-inch pipe, that's what that means. Okay, now we're going to start talking about chaining. Did you bring your Gunther's chain?
I forgot it.
Okay, that's okay. Normally Charlie brings out his Gunther's chain, but okay. This is a 200-foot tape, and this is called an ad tape. Remember I talked about this morning? And remember, ad tapes are fully graduated throughout, And only they're graduated to the foot throughout, and then at the end they're graduated to hundredths of a foot.
This is 0 right where my finger's at.
So then if we were going to measure between 2 points, let's go ahead and measure from the cone over here. It takes 2 people to measure, remember? So we're going to measure between 2 points. So I say 13 and Kurt says
63.
so then the distance is 1363 between the 2 points. It's supposed to be a little more accurate because you have 2 people reading the measurements instead of 1. Okay, now when we chain between 2 points, we can do it 2 ways. We can either chain flat, which means the chain is on the ground between points A and B, and that was kind of what Kurt and I just did. Or you can tape suspended, which means the tape is up in the air. So we're going to do an example of that right now, aren't we, Kurt?
Yeah.
We're going to do a plumb bob. So you and Charlie, we're going to do a plumb bob between points A and B here. So Charlie, you're on point A, and Kurt, you're on point B. And remember now, if there was a big disparity between elevations, Kurt would take his hand level out and get level. But this we can pretty much eyeball. So then we look between the 2 points, and it's 17 over here. What do you got, Kurt?
38.
38. He's pretty good, isn't he? Like that? It's exactly 1738, okay? So that's an example of chaining with a suspended tape. Now, most of the measurements that are done today are usually done with either the electronic distance measure or an EDM. And we're going to talk about those momentarily. What I first want to talk about is, remember, we're going to talk about horizontal control and vertical control. The first thing we're going to talk about is vertical control. And vertical control is the leveling process, right? So we need 2 things here when we're going to do leveling. We need a rod and we need a level. And we need a benchmark, right? So we're going to go ahead and set up this level. Okay, Alec, come on over here, man. We're ready for you. Okay, so I've leveled it up. You can see that the bullseye level is in the center.
Okay.
Okay. And now we're going to go ahead and look through the telescope. And Charlie is going to go over there. We've got a benchmark over there. And Charlie's going to put the rod on the benchmark.
Focus with this?
No, this one right here.
That focuses right there.
I'll tell you what, Kurt, why don't you focus in on it? He just look at it. Or you got it, Alec? Okay. All right, now, gang, where is Charlie? What is that called over there? Backside. Okay, remember that? Backside. All right, so we're going to read the backside. Alec's going to look through there.
Okay,
He's going to
6-1 and then 1 mark.
611 then?
Yeah.
Okay, then yell it out to Charlie and he'll verify that.
611.
And he'll put his finger on it, and then you look and see if it's right. Does that mean good? Does that mean good, or you want to go up farther? Okay. The thumbs up.
Scuba diving.
Thumbs up. Yeah. Usually like that. Yeah.
If you're looking back to
Okay. Now, what's the elevation over there, Kurt?
100.
That's exactly what I thought it was. Okay, the elevation on the benchmark was 100, guys, and the and the rod reading on the foresight was, Alec? 611 on the backside. Yeah, good. I'm glad I just checking you on that. Okay, now we're not doing the balancing the foresights and backsights because of space constraints, but Charlie now is at where? What's this called now? A foresight. Okay, now we need another volunteer. Come on over here, sir. Your name?
John.
John. Oh, fantastic name. Okay. Okay, so John's going to look through there.
Oh, thanks. I know he took his glasses off.
And he's going to go ahead and read the elevation there.
8.6.
286.
That's right.
Okay, good. 286. All right, now guys, I want you to calculate the elevation of that point over there. Kea here, he's going to read stadia. And what are you going to do, Kea? Which hairs are you going to read?
So you top and bottom one.
The top and bottom, right? Okay, guys, Kea is going to read stadia. I want you to write this down. The top hair is?
3-1.
3-1 what? 310?
Yeah.
310? Does that look right? Yeah? Okay, that's good. 310, is that the top or the bottom?
That was the top.
Okay, the top is 310, and the bottom is? 262. 262, Charlie. 262. Okay, the stadia interval is 100. Something's not looking right here. What is the difference? 1.48 feet?
That's 0.48.
Oh, okay, that's better.
It's 48.
Okay. All right, now we're going to get the chain out and we're going to verify this distance here. Well, how far is it from here to there?
48 feet.
Okay, let's check it out. Okay, we're going to verify the distance here. 48 feet. Yeah, perfect. No. Well, not really.
46 feet.
46, okay. Yeah, exactly. Okay, we got within a foot. So that like I said, that's not only accurate to that. Remember, at this close distance, if we're off as much as 100th, that's a foot. Okay, so we may even read the rod a 100th off or something like that. But you see how stadia works there? We read the top here, we read the bottom here, multiplied by 100, we got the distance. And we actually verified that by chaining it, okay? Okay, right?
Yeah.
Okay, ask a question, well, what if it's at the bottom of the line or the top of the line? Does that make a difference? It does. Okay, here's 5. 5.1 is the next one up, and then on top of that is 5.2. So 5 and 5.1, 5.2.
But when the crosshair is like right at this top part,
Yeah.
as opposed to right at this bottom part,
well, like in between.
Yeah.
Then you could
are
interpolate,
we supposed
but we're not going to do that today. You know, to the nearest 100th. Okay, so here's 5.3, 5.31, 3.2, 3.3, 3.4, 3.5. You see the pointy one there in the middle? That's halfway. So all the ones that are pointed, that's 5, that's an even number, and that's halfway, even number, halfway, even number. The red number there?
Width matters. The width of the lines matter.
Of course it does, yeah. And the red number here, that's the foot.
That's
Okay.
one number right.
Sometimes you'll hear the instrument go, raise for red. In other words, they can't see any of the red numbers, so you just go like this. Another thing is you might hear the rodman, the instrument say, wave the rod. That doesn't mean go like this. Hi, how you doing? That means go like this. You wave the rod to and from the instrument, and the instrument man will read the lowest number, okay? You do that when it's kind of hard to read. So when you're like way far away, maybe a couple 100 feet away,
What about mirage?
you go like that. Yeah, you'll see that. What about a mirage? You'll look through there. It's heat waves, actually, is what you mean. You look through there, and the crosshairs, they'll be like going like this. So usually, what you do there is you have them wave the rod, and you kind of make a guesstimate, or you get closer, because when you get closer, the heat waves.
We have to settle the elevation? That was the distance to that.
Okay, yeah. Well, it's going to be. We got the HI here, and then we had what was the center hair reading over there, Charlie? you remember? Does anybody remember?
103.25.
103.25. That's the elevation over there. So Charlie, write that down in the keel on the curb, please, so we remember that.
So the big number is the 1 foot?
The big number is the 1 foot.
And this is the half.
Well, no, this is still, anyone in red, that's still the big number. That's the foot.
That's 25 the foot.
Yeah.
Okay, you have two, so you have more
Yeah.
range.
Okay, this rod right here is called the Philadelphia rod. Remember that, the Philadelphia rod. Remember, it's fully graduated from 0, I think it goes to 13 feet, doesn't it, Kurt? Yeah. 13 feet. And you can use this when you're doing differential leveling. You use this kind of rod, okay? There's another kind of rod that we're going to look at. And this is another kind of rod, and this is called a linker rod, okay? Now you see when I move this up and down, nothing moves, right? See where the 8 is there? Doesn't move, does it?
What's the other one called?
Philadelphia rod. The other one's Philadelphia rod. This is called a linker rod. This is what's called a self-reading or self-reducing rod, okay? There's no need to keep notes with this one. This is not used for precise leveling. It's once you have established your benchmark, then you can kind of walk around and get elevations wherever you want. So what we're going to do now is we're going to do the same thing that we just did with a different rod, and there's no need to keep notes. We already know that the rod's going to take care of it, okay? So I need another volunteer here for the instrument. Come on up here. Okay, now we're going to do the same thing we just did, but this is with the linker rod. And remember, this is self-reading, self-reducing. There's no need to keep notes. This is the beauty of this one. So what we're going to do here, we're going to read the rod and tell Charlie what it is. And then Charlie will adjust the tape by moving it up and down to set 100. Remember, the elevation of that benchmark is 100, right? We already know that. That's a given. This one actually reads from the top down.
Oh, from the top down?
Yeah, so keep that in mind when you're looking at it.
6.2.
6.2 what?
Sorry, 6.20.
620. Okay, now you'll see Charlie, what he's going to do is put his thumbnail on 620. He'll unlock the tape, he'll roll it up, and he'll set his thumbnail to 000 because that's the elevation over there. And hopefully, okay, you're next. I bet you already know what you're supposed to read, right? Or do you?
Whatever he said the elevation was over there.
No, over here. We're over here now. So you should be reading.
Point one word.
No, 000 over there. 100, yeah. This should be 100. And then we're going to go over there, and then you're going to read that, yeah, without taking any notes.
I know, huh?
Take less notes, not no notes, right?
Yeah, less notes, yeah. Okay, so you should be you see that big X there? You should be reading that right on the X. That's
042.
042, yeah.
Off about 4/10.
Yeah, well, I don't know what happened. We missed the
If it was
4/10.
6 like this, that's
Remember,
what
it
like
increases
6.1.
going this way. Yeah, you're going the
6.2.
wrong way. That's close enough.
Okay.
Good. Okay, now, when Charlie sets his rod over this point, what should it read? What should it read?
Read the elevation.
Whatever we had there. Okay, Charlie, we're going to check into the benchmark here.
3.25 is what our original reading.
There you go.
was, but
So you can go ahead. You want to read it again, or you had enough? Okay. So then Charlie should read 325, and that tells me the elevation of that point. You have to keep track of the 100 yourself. The rod will keep track of the feet, the tenths, and the hundredths of a foot. But you need to keep track of the big numbers, okay? So Charlie's going to set up there. We're going to read it.
What's it supposed to be?
325. Perfect. 325. Okay guys, now we've just done some differential leveling, we've done some linker rod leveling.
Charlie, go back.
Now we're going to do a couple things that we talked about in class. Okay, what do you think? 3, 2, 3? 3, 2, 3. Yeah, that's good. Yeah, that's good. Okay, Charlie, bring the rod over here, please. Now again, let me see your pencil. Yeah. Okay. Now we're going to get a close-up view of what Charlie did here, okay? Remember that, let's say I set up the rod over there and Charlie and the rod person read 280. Where's 280 at? I'm sorry, 180. 180 is right there, right?
Yeah.
And what is it supposed to read? 0, 0, 0, right? So I unlock it here. I roll the tape till it goes down to it reads XXX. I lock the tape back down, and now it's all set to go. So anywhere that I go, the elevation is right off the tape, okay? Now we're going to do some cross-section and profile leveling, all right? You guys ready for that? Let's do a cross-section first. We're going to do it over here. We laid out a baseline. So if you guys would, just everybody get behind the camera here. Yeah. Well, no, it's all set to go. Okay, we're going to do a cross-section. Now, you see what Charlie and Kurt have done? They've laid out this baseline. That's station 0 plus 0, 0. Here's 0 plus 25. We're going to do a cross-section at station 0 plus 25. Now remember, there's two parts to a cross-section, right? What are they? Elevation and what else? Exactly, okay, so we're going to need the tape too. And we need somebody to read the rod over there, so we need another volunteer there. Anybody? Somebody that hasn't done it yet. Okay, here we go now. Okay, so what is it at center line? Yeah. Okay, that was fun. All right, 878. Let me point it out to our man here. 878. You see? We got 8 is the red number. Then we have the 7. And then the 8 comes right here, 878. Okay, when I take a cross section, when am I going to take another elevation here? When what happens? The grade changes, right? So I'm going to go out here to when the grade changes. Oh, here I got to go. Okay, so from this point, we would have an elevation and a distance. Are we right or left here, guys? Right, because stationing is increasing that way. Okay, that's good. And then I take a shot here at the top of curb. And then another one back here. Okay, and then I'd go on the other side and do the same thing. Okay, is that clear? Cross-sectioning. We talked also this morning about profile leveling. And that's where I'm going to take a series of elevation along a given baseline. Here's our baseline right here. So it's station 0 plus 25. All right, here, give it a shot here. That's still the same guy, it's a different guy. Oh, excellent. Okay, and now where do I go next? Next station. 860. Okay, perfect. All right, any questions about that? Vertical control. We did everything that we talked about in class today, yes.
The profiling, is that the one where you just keep the tracking foresight until you have to turn?
Yes. Well, in this case here, we were using the linker rod, so we didn't have to do the subtraction. But if we had the other rod, we'd establish the HI and then subtract, subtract, subtract. Okay? Any other questions about vertical control? Okay, now we're going to talk about horizontal control. Okay, now Kurt's going to be setting up a transit over top of this point here that we've established on the ground. And this is, what kind of a control point this is? Horizontal or vertical? Horizontal control, excellent, okay. So we're going to set up our point over that. We're going to go ahead and get the Plumb Bob over that. And remember I said there's some specific differences between a transit and a theodolite. This is a transit. It's used to measure horizontal and vertical angles. And you'll see that Kurt is, you see how he's leveling it up. He's moving his thumbs in opposite direction. And you'll see if you look over his shoulder, the bubble will be moving the direction of his left thumb. Okay, so do it again, Kurt, so everybody sees.
Bubble moves to the right. Left thumb goes to the right.
On the example, I'll ask you a question like,
The unique thing about it is the Plumb Bob. You need to have the Plumb Bob to get this thing over the point. Kurt talked about the upper and lower motion, right? Okay, so, and this one here is probably about the 1950 model, and this is one of Kurt's pride and joys. A lot of surveyors collect antique instruments, and Kurt has quite a big collection, and he was generous enough to bring this one out today to look at it. These basically didn't change a lot until we came up with the theodolite. The big change was in like the 1800s, when the telescope was so large up until 1800 that you could not transit the telescope, okay? So the reason this was called the transit was because you could actually invert the telescope and prolong a straight line without turning 180-degree angles. Because of the optics, the telescopes in the old instruments were like this long. The only way you could prolong a straight line was to turn 180 degrees like we talked about in class. Okay.
About the upper and lower, you were saying that I guess the lower is to get it at 0 first, and then you'll turn the deflection one.
The initial sighting is using the lower motion.
Right.
When you start measuring the actual angle, you loosen up the upper motion. And then there's other issues that
I'm
go
sorry,
with that.
lower motion, what do you mean by that?
In other words,
What happens is you lock the plate onto 0, and if the lower motion is unlocked, you can move it all over the place and it's still going to be at 0, okay? When you lock on a target, you lock the lower motion and you unlock the upper motion. Now the vernier moves and you can measure things, okay? That's the purpose of the upper and lower motion.
Can I call the deflection, measure the deflection angle, or is just a horizontal angle?
We can do a deflection angle.
backside, whatever you're measuring at your backside.
Okay, so Kurt's gonna, so let's go ahead and spread out a little bit, and Kurt's gonna measure a couple angles for us, okay? And the first thing we're gonna do is something called doubling an angle. All right, so we've set a sight down there. Charlie, where are you, buddy? Okay, would you set your sight down there on the line? And then let me have a red pencil.
The green one.
That's good. Get arrested for graffitiing. Okay, Kurt's going to turn an angle, and we're going to do this process called doubling an angle.
Plus 75 station.
So he's going to sight along our baseline that we've already established, and we're going to turn a 90-degree angle, and Charlie's going to take line over there. So he's going to tell Charlie where to move, either left or right, to be on that line. So we're just going to turn a 90 degrees. It's going to unlock the upper motion now. Set 90 degrees on the top. Lock it down.
Because this thing is so small, they also supply you with this little thing here,
Jeweler's loop.
magnifying glass.
AKA magnifying glass.
Left 2/10. Left 5. Left 5. Left 2 and good.
When he says that means 500ths. Okay, 500ths left. Okay, now Charlie has more marked, so now we know that this line here that we created is exactly 90 degrees from that line. But to make sure that, we're going to do what's called doubling an angle, okay? So Kurt's going to do that. He's going to invert the telescope. He's going to unlock the lower motion, sight down on our baseline, and then he's going to turn an angle of what? Okay, take a guess. Come on now. This was 90, so he's going to do 180. Now it's still 90. It's still 90 now is his initial reading. So now it's going to be. It depends if you read the B vernier or the A vernier. Yeah. Okay, and then he's going to tell Charlie where to go. See if he's still on the same line. Now imagine, if you will, that the instrument was like way out of level. All right, even though it's not. Let's exaggerate that. So when you turn this double angle, if it was off this much, when you were looking at the first direction, when you doubled it, it would look like this, right? So that compensates that error, okay? That's why you do the doubling of the angle. So Kurt's going to go ahead and put, are you looking at the B vernier or the A vernier?
Looking at the B.
So it's 270 then. Or no, it's 180.
It's actually a 360.
Okay, yeah, 360. So the A vernier would be 180, 90 plus 90. Okay, and then Charlie is being
left 2. Good.
So it's a little bit off. It's like 200 off. So what Charlie would do is he'd take the difference between the two readings, split it, say, okay, this is where it is. Okay? That's called doubling an angle. Let's do prolonging a straight line. So Charlie, we're going to go over there, prolong the straight line, please. So now Kurt's going to sight back down. You're going to sight down and flop. We're going to prolong the straight line. So this is kind of similar, but we're just going to invert the telescope. So we're going to sight down there. And then just invert the telescope. Sometimes they'll just say flop the telescope or invert the instrument. Now you'll see the terms called reverse and direct. If you were in the direct mode, you see the focus knob here? That would be at the top. Because the level is at the top now, this is called the reverse mode.
And you expect to get that point?
We're going to prolong this line through here. Okay? Instead of turning 180, you just invert the telescope. He'll again show Charlie where to go, make a move left or right. Oh, you already got a point back there, huh?
Well, you can because it's not at.
No, we're not exactly on the other point. Yeah, that's right. Yeah.
Left 3/10. Left 2/10. Keep going, stop. Right 15. Left 2. Good.
Okay. And then what Kurt would do is to go ahead, unlock the lower motion, sight there again. Just do it real quick, like you don't even have to like do it for real, just flop it around. See, now he's looking direct because the focus knob is on top. He'd sight on that, which you already did, that's okay. And then just flop over again, tell Charlie where to go, Charlie would take the difference, okay? That's called prolonging a straight line. Okay, in around the late 1950s, early 1960s, they came up with a modern instrument to replace this. It's called the theodolite. So Kurt's going to put this one away. He's going to bring over our theodolite, and we're going to take a look at that, and I'll show you the differences between the old style instrument and the new style instrument. You can see the basic difference. When this one is, the vernier is inside. If you look into the small hole on the left of the telescope here, you will see the internal vernier. That is how you read the angles. Also, this one does not have a plumb bob. It has what's called an optical plummet. So if you look down through this bottom eyepiece here, you can get the point exactly over the survey point, all right? After you do that, you level it up and you're good to go. So those are kind of the basic differences. The theodolite that we were looking at, is that a 1 minute, Kurt?
Yes.
It's a 1 minute, so capable of reading direct to 1 minute. This one is capable of reading angles to the nearest second. So a much more accurate piece of equipment here. Much more expensive too. So once we get the point over that, we can go ahead and do whatever we want to do again, okay? Now, we're going to talk about one other thing, and this one is often on the exam. It's called, and I want you to write this one down. We didn't talk about this in class. It's called interlining, okay? Interlining. Now let's assume for a minute that Kurt is sitting up here on a hill, all right? All by himself, there's nobody here. This is line AB. It starts there, it ends way over there. So he's looking down there at point A, he's looking down there at point B, and he has to get on this line, okay? And that process is just moving back and forth on a trial and error basis until you get on the line. So for example, let's go ahead and we're going to take the thing. And I'm on top of the mountain now. Yeah. Thanks, John. I just spent all that time. I'm on top. How do you do this, Kurt? I'm on top of the mountain now, okay? And I need to get on line AB. So the only way to do that is kind of guess, all right? You take your plumb bob out, you look over at line A, and you say, all right, yeah, okay. I think I'm somewhere around here, and then another thing you could do is do the old wing ding, like Kurt says. You kind of go like this. You kind of go back and forth like this. Very precise, you know, and you say, okay, right here,
Actually,
bingo.
you can get pretty close.
You can get pretty close.
Yeah.
Believe it or not, you can. One of the things that we do at like surveyor parties and stuff like that is we do this. We go like this.
Dance.
You do an angle of 90 degrees. You go like this. And then you give the guy line, and then you take out the instrument and measurement, and then whoever gets the closest wins like $1 million. Okay, so this interlining process then is you're on top of the hill, you want to get on line AB, you do a trial and error method, so Kurt would look down there, he'd invert the telescope. So just do like one time, that's good enough. So
just pretend I leveled it up.
yeah, leveled it all up, sight there, invert the telescope, and he says, okay, I'm missing that one by about a foot. So he says, okay, I got to move over about half a foot. If you're in the middle between the two, you can actually get, if you don't get it by the third time, it's very embarrassing, you know. Kurt usually can do it in 2.
or thereabouts.
Same principle applies.
I'm sorry?
This only has 3 leveling.
Okay, good question. How come this one only has 3 leveling? What do I do? Which way does my thumb go now? Okay. Actually, this one here, you just kind of follow the bullseye bubble will tell you which way to go.
You put it over.
You put it over 2 of them. And does it still work the same way?
Well, you put it over like that, and now you use 2 of them.
Yeah, so it's still the same thing. Yeah, but you do 2 at a time.
Well,
So you do those 2, and then you do
this
those
one.
2.
No, you do that one.
Yeah.
Like that.
And you have to have the machine perpendicular.
Okay.
Anyway,
So there you go. So that would
it's
be
a lot easier.
Yeah, it's easier to set this one up, definitely. A real kind of a skill challenge, another skill challenge is, you'll notice that those tripods are stiff-legged. These ones here you can move up and down individually. So imagine if you're on the side of a hill trying to set up a stiff-legged tripod with a Plumb Bob. It's a pretty good challenge, all right? And there's not too many people around. Only the old timers like Kurt and I can actually do that stuff, because people don't use those instruments anymore, you know? So, interlining, we talked about doubling an angle. We talked about prolonging a straight line. Okay, that's the process. And then we also talked about measuring horizontal angles, right? Vertical angles is very simple. If you look through here, there's a V on the vernier that means vertical, and the H stands for horizontal. So if you turn your vertical angle, you just turn it up there and read it, and whatever it is, okay? And this is a vertical angle or is it a zenith angle?
These are zeniths.
Oh, okay. So this is all a zenith angle. So remember, 0, 90, 180, 270, 360. Okay, so zenith angle. So we're going to talk tomorrow about traversing, and that's a way that we're going to establish horizontal control. We haven't talked about that yet, so I don't want to talk about that today. It gets you all confused. What I want to talk about next is we're going to talk about the total station, and that is the next instrument. So Charlie, would you bring the total station over here, please? And the total station is a machine that has the ability to measure horizontal, vertical angles, and distances all at the press of a button. So we're going to set this up here on our control point. And go ahead and put this one away, Kurt. So we'll keep these, we'll keep these set up over here, and afterwards, if you want to come look and see, and we'll let you do that. We're going to set up the total station now, and Charlie, would you get out the stakeout rod, please? And so the total station, again, has the ability to vertical angles, horizontal angles, and distances all through the same telescope. You see that box on the side? That's called a data collector. So when Kurt just presses the button, the horizontal, vertical angle, and distance all get input into the data collector. When you get back to the office, you now can generate X, Y, Z coordinates for everything.
Distance, that's the EDM, right?
That's the EDM portion in there, yeah.
A little light beam bounces back.
And it measures the time that it takes. Very. You can measure distances like up to 25 miles.
That's not
Okay.
distance, precision.
Okay, they are, like this one here is plus or minus 200 plus 3 parts per million. So it's accurate. It's very accurate.
Initialize it. You have to initialize it also, right?
Yeah, we're going to do that. We're going to initialize it. Now you have to initialize it on a baseline, okay? So we're going to backside on this baseline, and we're going to do the radial survey. Remember, we talked about the radial tie-in. So we're going to do that. So Charlie, let's just where you have your sight there, we're going to use that for our baseline.
Did we come up with an elevation for this? Do you want to worry about elevation here?
No, we'll just fake it. Okay, we're going to do a radial topographic survey now. Okay, we're going to do a radial topographic survey. We're going to this is our baseline. We've already established this. We know where this is in relationship to the world. We're steadying on station 0 plus 25. We're sighting 0 plus 75. We know what the bearing of this line is. We know what the HI of the instrument is. We know what the elevation of that point is. So Kurt would just go ahead there, sight on that point, press one button, and he's initialized. And now from that point, he can radially locate the bearing and the distance. Okay. Excuse me, you gotta wait for that. You can't do that yet. Come on over here. We don't want anything to happen to anybody or anything, but we'll set it up for you right after we're done here, I promise. Nice and low too. Okay, so Charlie is down there. We're gonna go ahead and initialize on that, and Kurt's already initialized on it. Okay, now Charlie can locate any point here. A topographic survey, so we're going to locate all of the curbs all the way around the parking lot, okay? Because we need to know that. So Charlie, okay, good, we're good. We're going to locate all the curb returns. You have to come out a known bearing. That's called our basis of bearings, and we'll talk about that some more tomorrow. And in the data collector, you can input codes for each point. So if Charlie's at the middle of the curb return, he just tells him on the radio, and Kurt puts in a special number that it signifies that. So when you draw out the map, it tells everything where it is and what it is. Okay, good?
Okay.
Now we're going at the curb return. We'll take another point.
This only works with the stick. He can't just point it at a spot on the ground.
They actually have what's called reflectorless out now, state-of-the-art technology, which can do that. Same accuracy too.
Half the surveyors.
And half the surveyors, right. Yeah, there's a lot of things you can do with one person now. Kurt does a lot by himself.
What's that called that's in his hand?
Stakeout rod. And remember what we'll do here, guys. You see, Charlie, show them how you can move the stakeout rod up and down vertically. Charlie will set the height of target to the same height of the instrument. That way we don't have to worry about the differences there. So if we want to measure our HI, you got your yo-yo there? You see the dot on the side of the machine? We would just measure from the ground up to that point, and then you input that into the machine, and you also have the elevation into the machine, so that way if it turns a vertical angle, it can determine elevations everywhere that you look.
Does that get related to the rod?
Actually,
You can change the HI on the rod anytime you want.
You can,
as long as
yeah.
you know what it is, I'm able to put that in and it'll compensate for any changes in the rod itself.
you can either make it the same or you can make it different, and as long as the machine knows, it will automatically calculate things for you.
Once you've set it and you're doing you're running around taking shots, you gotta leave it there, right?
No, you can change it anytime
So you gotta
want
know
to,
the-
as
you
long
gotta-
as
You-
he lets me know.
You can change it, but you have to put it in the machine.
Gotcha.
Yeah.
John, do you still have to flip this thing, transit this thing, and take veneers, AB, just like you do with
This
the
is
others?
this is all a digital format, so the making of the plates are all electronic, if you want to call it that. There's no handmade, so to speak, no machining process.
There's what's called no eccentricities in the plate. That doesn't happen. So you don't have to double the angles and all that stuff.
The manufacturing process.
It's all electronic.
Yeah.
So you don't have to do that anymore.
But you'll see that it has a screen on both sides. So you can transit the telescope and work on it from the other side, okay? If you wanted to. Yeah.
Yada, yada.
Yeah. Okay, now, that's an example of a topographic survey. We could also do a construction survey where it's just the opposite. Let's pretend we need to locate some of the curb over here. Okay, the whole thing is just bare dirt, all right? There's nothing here. The contractor wants to come out tomorrow and pour curb along here, and the surveyor is going to come out and say, okay, this is where I want you to locate the curb. So we would kind of do it just the opposite. We'd have our established horizontal and vertical control. Kurt would calculate where all the curb points are supposed to be. He'd input those coordinates into the machine, and then he would measure where Charlie is and tell him where to be. Okay, so we're going to do that. This is kind of just the opposite. That this would be a construction survey. Yeah, and remember I said earlier that we would do it on an offset. So when Kirk did his calculations, usually curbs are staked on a 3-foot offset. So we would establish a line 3 foot parallel and concentric to that curb on the plans, calculate the coordinates, input those into the machine, and then Kurt would be able to go ahead then and tell Charlie where to go. So Charlie would kind of take a guess at it and say, okay, here I am. Kurt would take a reading and then tell him to move left or right, forward or backward from that point. Okay, so we've got our input here, and Kurt knows how far he should be.
Away 2/10, right 2/10.
So then Charlie would go ahead and then locate that point. Kurt would take another reading to make sure he's where he's supposed to be. And once he got there, he would go ahead then and put the stake into the ground. Okay, that's good. Normally we'd pound it flush into the ground. Okay, so, and then we'd go to the next one and do the same kind of thing. So that would be an example of a construction survey. Okay, any questions about that stuff? Okay, the staking? Yeah, that's exactly what we did. That's staking.
You're gonna put, you know, label.
Oh, you mean we're not going to talk about that yet, but that's called the witness stake there, the one with the flagging on it. That would have some certain markings on there so that the contractor would know what to do. And we won't talk about that yet, but we will. Okay, enough about that. We're going to go ahead then and break set up here. We just got a couple more things to do, and we're right on schedule. So if you'll come over here, please. Bo.
At that point, when you put that in, the data collector in the office, you've downloaded everything, grades, coordinates, so on and so forth. So you'll take a shot on that after you put the hub in or the stake in, shoot that, it'll tell you whether it's a cut or fill. So there's a lot of human error that's taken out of that, as long as the input is correct, of course. As long as the engineers give you the right data.
Yeah, you know, garbage in, garbage out kind of thing. So that kind of deal. Want to talk about one last thing and then we'll wrap it up for the day. And if anybody wants to stay and get a little more hands-on, if you do want to touch and feel things, make sure one of the crew is with you, okay? We need to make sure that nothing happens to any of the equipment or nothing happens to you guys. This is a GPS receiver, and this is kind of state-of-the-art stuff. This is how we now establish horizontal and vertical control on a site, and it's all happening. You can't see them up there because they're 12,000 miles away, but there's a constellation of satellites above, and if we know where those satellites are, we can determine where we are on the face of the earth. And I'll talk about that as we get into, I think is it tomorrow? Maybe tomorrow or Saturday of next week.
What kind of time delay do they provide the information?
For what?
Well, they give you very precise reading of location and elevation, I would imagine.
Yes.
So what kind of
When do you get it? Okay.
Yeah.
Well, you can get it a couple different ways. You can get this is a static machine, so you need to have a setup here for at least what 2-3 minutes.
No, this is basically this is tied into the Orange County.
Oh, it is. So you get real time with that. Okay. We're getting a little ahead of ourselves, but there's a couple different ways you can do it. There's called a static machine, and then there's what's called real-time kinematic, and that's what this is, real-time. So this will tell you at an instant, this is where you are on the face of the earth, X, Y, and Z coordinates, okay? So pretty amazing machine. We'll talk, when we get into the lecture, I'll tell you how it works and with the accuracy and all that kind of stuff. It's not very exciting to look at. You know, you just press the button and turn it on and it's working. So it's not all that interesting to look at. There's also one that, you know where Charlie's little stakeout rod is? They actually have them like that where you can walk around. You could actually use this one as a rover, right, Kurt?
Yeah. Basically, I can download data into this machine too. It's not quite as sophisticated as the total station is at this point here, but there are other ones like John was saying. The rovers that have all the design data in it, and you walk around and you can stake everything from that. It'll tell you cuts, fills, whatever.
Or handheld device.
This one basically is like this with a data collector on it.
Yeah.
And you got
It doesn't have these two
doesn't have
things
on
here.
this, yeah, I mean,
It just has the one pole.
It's for a rough grade, initial grading situation for the most part.
So this is a one-person operation.
Well,
You just walk around with this thing,
Yeah.
big or small. Just take pictures.
so they say, but the surveyors are carrying so much.
This will establish horizontal and vertical control from the satellites.
I don't know if there's another guy with a stick.
So you set it up over a survey point, you let it collect the data, and it will tell you this is the XYZ coordinate of that point.
Satellite. That's what it's doing, right?
You got four. You really need four.
It's actually called trilateration, but we'll talk about that tomorrow. But you're close. You're close.
Do you have to have some special, is there some sort of special security device that you have to buy into the county because it's giving you real time?
Well, basically, it's their modem. a special modem that they've used, but you don't have to. It just makes it easier because it's a direct dial-up.
Yeah.
It's a dial-up type situation.
Yeah,
Like
and we'll
a cell
talk
phone.
about that. We'll talk about that. It's pretty interesting stuff, the GPS, and we'll talk about that. Okay, guys, it's almost 4 o'clock, so our day is over for today. And I know you'd like to stay another 3 hours, but we're going to have to stop for now. And we'll continue tomorrow at 9 o'clock. We'll continue. I want you to make sure you do your homework that I talked about in class this morning, and get a good night's rest. Tomorrow is going to be another great day for us. Anybody that would like to stay, we'll be here as long as it takes. If you have additional questions, if you'd like to come and play around with the instruments a little bit, look through the telescope, look at the verniers and so forth, and I invite you to do so. Just make sure one of the crew is there with you, okay? So for those of you that have had enough for today, have a good evening, and I'll see you tomorrow morning. And anybody wants to stay, just hang out and we'll go out and answer your questions, okay?
Quick question relating to grading again. When we lay out the stakes like the first time,
Mhm.
like at some sites you're doing a big commercial.
That concludes our field demonstration on the equipment and methods used in engineering surveying. Thanks for joining us here at the Irvine Institute of Technology. If you're interested in any of our classes, please visit our website at www.irvine-institute.org.